Alrighty guys, so I'm going to do a quick review of what I taught last block on section 8.1, which is applications of the definite integral. Okay, so what we did was we used the definite integral to find net and total distance traveled. You need to know these two equations or expressions, that the net distance is just the definite integral from a to b of velocity. And if we want the total distance, then we have to take the absolute value of that velocity from a to b and integrate it, and we get our answer. Alright, so remember that our answer is going to be some number, right? We're not going to get a function, we're going to get a number. So when velocity is positive, that means the object is moving to the right, and when it's negative, the object moves to the left. So I believe I did this problem in class, so I'm just going to reiterate it again. This is number 2 from the homework section, and you were given that the velocity of an object moving is t squared minus 6t minus 8, and the time interval was from 1 to 5, and you're asked to find the net and the total distance traveled. Well, I added a question in here. When does the object change direction? Because on AP, chances are you might get that question. So what you want to do is, of course, put the function into your calculator and hit the graph key. Oops, I got another function coming up there. Hang on. Let me just turn that off. Come on. Stop it! Let me just turn these two off because this is going to be for another example, so I wanted to get it in the calculator. Now remember, you need to see the whole function and its intercepts over the interval that you're dealing with. So our interval here, just fix that a little bit, our interval was from 1 to 5, right? That's what was given in the problem, 1 to 5. So anyway, what I can see by graphing this velocity function is the velocity is positive from, say, negative infinity to whatever that intercept is. It's negative from this intercept to this intercept, and then it goes positive again. The other thing I can see is that all of the area between the x-axis and this curve on the interval from 1 to 5 is going to be concentrated below the x-axis, so I would expect that we would get a negative answer, right? So there's some things that we have to think about in order to put this into perspective. Okay, so the first thing I want to do is, if I want to figure out when it changes direction, and I know it's going to be at the intercept, so remember this only happens on the graph of velocity, and I apologize, but I'm getting this very grainy screen here. Maybe it's my lighting. I'm trying to fix my lighting. Well, I hope you can see that okay on the video. I'll check it once it's done. But you know, in AP, you can't just say, well, at -1 and what is this, 2, 6, 7 or 8, right? No, they're going to want it precise, and they're going to want it to 3 places past the decimal. So what you're going to have to do is a second calc 0, 2, right? And if I want this point of intersection, or intercept over here, I've got to go a little to the left and press enter, and a little to the right and press enter one more time. And I can see that, you know, this object changes direction at x equals negative 1.123. Okay, so I'm going to write that down. At x equals negative 1.123. 3 places past the decimal for AP. And then I'm going to find the other one, right, because it's moving to the right up until negative 1.123. Then it becomes negative, so it's going to move to the left until it hits this point, and then it's going to turn around and start moving to the right again. So again, I'm going to do second calc 2. And I'm going to move over a little bit closer to that other intercept with my arrow key. Okay, so left bound, I'm going to press enter, move a little to the right, press enter one more time, and it looks like that intercept is at 7.123. So those would be the places that my object changes direction. Okay. And so that's often asked. A lot of times too, it's asked, you know, on what interval is velocity positive? So you could say, you know, if we didn't have this time interval, you could say, well, velocity is positive from negative infinity to negative 1.123 and from 7.123 to infinity or something like that. So you can use interval notation. You can use this notation right here if you needed to. All right, so anyway, that's when it changes direction. Now the next thing we want to find is the net distance traveled. And what we know is that the net distance traveled is just equal to the definite integral over the given time interval, so it was from time equals 1 to time equals to 5 of our velocity function. And if we integrate this, we're going to have t cubed over 3 minus 6t squared over 2 minus 8t, and we're going to evaluate that from 1 to 5, right? And when you're doing this work on an FRQ, this must be shown just like this. Then I went ahead and cleaned this up. I know I can divide 6 by 2, so I cleaned this up a little bit to make the computation a little bit easier. 1 to 5, right? And now I'm going to evaluate using the fundamental theorem. So if I plug the upper bound in, I'm going to have 125 thirds minus 75, right? 25 times 3 is a negative 75, and 8 times 5 gives me the negative 40. So this is my f of b minus, now I have to evaluate this function at a. So this is my a, I plug in the 1, I have a third, minus 3, minus 8. And then I've got to do some arithmetic, to clean that up, right? So a little bit of work here. And again, you can clean it up however you want. You can clean up what's in here and then subtract from it what's in here. You know, whatever makes you feel comfortable. What I can say is that the longer you put this process out, the better you're going to become at adding and subtracting fractions and whole numbers and whatnot. So anyway, these two have the same denominator, so I just distributed this sign to each one here. So I got a negative 1/3 and a positive 11. Adding the whole numbers and the fractions together, we get 124 over 3 minus 104. And now we can clean this up again. 3 times negative 104 is negative 312 plus 124. It's going to give us a negative 188 over 3. And again, that makes sense that my answer is negative, and all that means is that, you know, the area is really concentrated below the x-axis. So if I want to do it on my calculator, and we do, then what I'm going to do from this screen is I'm going to do second calc and then 7, right? You see the little integral there. And, you know, it asks for a lower limit. Well, it's 1, enter. The upper limit is 5, enter. And it'll shade in that region and give you negative 62.667. All right. If I go to the home screen and I take the fraction, negative 188 divided by 3, well, I get the same answer. Okay, so how I would write this if I had to do it in a decimal, which again, this is calculus, so we very rarely write in decimals. We usually leave it like this, but you know, I could say that's approximately negative 62.667. Okay, and there would be some units. I'm not worrying about the units right now. All right, so now we want the total area. And the total area means that I have to take any negative area or values below the x-axis and bring them above, right? I need to make everything positive. So that's what this absolute value symbol is going to do for us. And again, you're going to use your calculator. So what you want to do is go into y equals, and I'm going to put it into y2, right? So to get the absolute value symbol, you need to do math, right arrow 1, and that throws the absolute value symbols in there. And then if you want to, you can either retype the function or you can do vars right arrow 1, 1. And what this is telling the calculator is I want the absolute value of the graph that's sitting in y1. And I'm going to go ahead and shut off the original graph because otherwise it's going to become too much, and I'm going to hit the graph key. And here comes our graph, and as you can see, at those intercepts, it takes all of that area that was originally below the x-axis and brings it above. And so now if I do second calc 7 from 1 to 5, it's going to shade in that region, and you notice I get a positive number, And by the way, this is a coincidence. It's usually not this way. So a minute ago we had, negative 62.667. This time we're having positive 62.667. And so generally the numbers are completely different. So don't think that just because the net area is negative, that means that the total area is positive. Okay, this one just happened to work out that way. All right, so anyway, we would say this is approximately 62.667. Again, rounding to 3 places. If you make a rounding error, you lose the point. You lose the point. They don't care. So you'll lose that point if you have a rounding error. So be very careful when you round 3 places past the decimal. That's the rule. Here's the other one. So let me move this up a little bit. The other example is this one here. This also comes from the homework section. So I went ahead. This is a weird little function. It's 5 minus e to the 0.5t. So not easily done by hand. The time interval is from 1 to 4. And we want to find the net and the total distance. So again, you're going to put your function into y1 or y2 or wherever you want. Mine's in y3. Okay? And I'm going to turn that graph on so I can get an idea of what it looks like. Now I know what e to the anything x looks like. This is negative, so it's a decreasing function. And, it's up 5. So this may be off somewhat because I'm in a zoom 0. So you could do like a zoom 6 window if you want to get a better look at that. Okay, so there's your function. And again, you want to find the net area, the net distance traveled, which is the same as the net area, on 1 to 4. So you can just do second calc 7 from 1 to 4 and hit enter. And you see there's area above and some area below. And the calculator, or the integral, is automatically going to subtract the 2. And so it looks like we get 3.519. Okay, so the net is 3.519. And if I want the total, well, I go to y equals, I'm going to shut this graph off, and you notice I put in math right arrow 8 to get my absolute value symbols there, and then I did vars right arrow 1 3, right? So let me just do it again. Right, so I'm going to delete that. Vars right arrow 1, and then we want to take the function sitting in y3, so that's why I'm pressing a 3, and hit graph. And so here comes our function, and you notice everything's above the x-axis now. And so if I do second calc 7 from 1 to 4, now it's going to add that area up, and as you can see, well, I don't know if you can see because it's in magenta, really hard to see, but it's 5.265. So this would be 5.265. That's it. You're pretty much going to be using your calculator for those. Now, when the object, or when the acceleration of the object is given, now you've got some more work to do. Right? So we went over a few of these in class yesterday too. When the acceleration is given, you're going to have to follow these steps. The first thing is you're going to have to find the antiderivative using an indefinite integral, no bounds. So that way you can find the velocity function plus c. Once you have the velocity function plus c, then you have to find c, and you're going to be given some information on how to find c. So you're going to be given, like, v of 0 equals 1 or something like that. So you're going to be given an x and a y value to help you find that. And then what you have to do for the grader is write out the velocity function fully. In other words, if our velocity function was x plus c, and we found out that c was 2, you'd have to write it out, x plus 2. All right, so you have to rewrite the velocity function in its entirety. Then you're going to have to evaluate the velocity function by taking the definite integral from the time values or the endpoints that they give you, whether it's net or total, per the instructions given, so that way you can find what they're asking for. All right, so in number on page 376. They're telling us that a of t is equal to the square root of t. They're telling us that v of 0 is negative 6. And they're giving us t equals to 0 and t equals to 9. Right? And they want you to find an equation for the velocity and then find the net and total distance traveled. Well, it makes sense. You have to find the velocity equation before you can even find net or total distance traveled. So, I know that velocity is equal to the indefinite integral of acceleration. Well, the acceleration function that they gave us was the square root of t. So you need to show this for the grader, right? And we want to rewrite that because we need to integrate it, so we want to make it easy. So it's t to the 1/2 dt. Right? So if I integrate this thing, remember, we're going to have t to the power plus 1. So that's t to the 3/2 over 3/2 plus c. And to simplify that a little bit, we flip the bottom, so we write it as 2/3 t to the 3/2 plus c. If you want to simplify it just a little bit more, you can rewrite it in radical form, and this would be the square root of t cubed plus c. Right? So, I have my partial velocity function. I need to find c. So, how do we find c? We find c by this statement here. They're telling us that if I plug a 0 in, the velocity is negative 6. So what I'm going to do is, I'm going to say negative 6 is equal to 2/3 times the square root of 0 cubed plus c. Well, the square root of 0 cubed is 0, times 2/3 is 0, so that goes away. So I know that my c is negative 6. So my actual velocity function then is going to be 2/3 square root of t cubed minus 6. There's my velocity. Now I can find the net and the total distance traveled. The net distance traveled, so again, even though you're using your calculator, AP is going to require you to write down what you're finding and showing it using mathematical notation. So this is the definite integral from what to what? Well, if I go back up and look, they gave me times 0 to 9. So those are my limits of integration. Okay? And I'm going to integrate this thing, 2/3 square root of t cubed minus 6 dt. Okay, so remember, even if you forget the dt, you're going to lose the point. It has to be perfectly the integral. Because if it's not, then it's wrong. So keep that in mind. Alright, and then we're going to use our handy dandy calculator because, well, the integration's not that bad on that. You know, figuring out the values might be. So we're going to take our calculator, move this over here, and I'm going to input this function, so I'm going to move this. And again, the function, so I'm heavy on the parentheses, as you know, because if you make a mistake with parentheses, you're going to get the answer wrong, so just be careful. So I do 2/3, 2 divided by 3 in parentheses, times, now I want the square root, so it's second root, right, of x cubed. And make sure you arrow out of there, okay, minus 6. You don't want your negative 6 to be under the radical because that's not the function. So I have 2/3 times the square root of x cubed minus 6. And I'm going to hit the graph key. And I want to make sure that my function is in my window from 0 to 9. Really important. So this is, I think this, I'm still in a Zoom 6 window, so we have 3, 6, 9. So yeah, I can see everything there, right? Because remember, if you don't, you're going to get a domain error or something. So to find my net, I'm just going to do second Calc 7 from 0 to 9. And it looks like that the net distance traveled, or the displacement, is 10.799, so we'd round that to the following. This would be 10.8, wait a minute, it was 10.799, 10.800. You see, even though it's 10.8, they want to see 3 places past the decimal. So make sure you put the zeros. Even if they're zeros, they need to see them. And now if I want to find the total distance, well, what I need to do is write the definite integral from 0 to 9, put the absolute value around that thing, put that into my calculator, and go from there. So I'm going to go to y equals, I'm going to go down to y2, do math, right arrow 1 to get my absolute values there. And I do not feel like retyping that in, and neither should you, so you're going to use vars right arrow 1, 1, telling the calculator you want to graph the function that's in y1. I'm going to go up and shut that graph off so it doesn't get too busy. I'm going to hit the absolute value graph button. It's taking all that negative value and bringing it above. And now when I do second Calc 7 from 0 to 9, all of my area becomes positive. So we're going to be adding rather than subtracting, right? And as you notice, we're going to get that the total distance traveled is 41.952. So this one is 41.952. And that's it. Alright? So keep working on your homework. Your homework was page 376. It was 1 through 15 odd. And we'll discuss any of those that you have tomorrow. You are going to have a little quiz, a few problems. Remember, I already discussed this with you on this topic. So you have, just a few questions where you'll have to use your calculator to find the net and total distance traveled. Hope you have a good night. Oh, I don't know if you could see that, so I just want to put that there, just in case my paper was out of the viewing window. See you later.